Oh, let me make sure it's recording. Yep. Okay, so let's quickly do the mapping. So for Python, remember we have variables, ask questions, repetition. That's our three things rather. So Python variables are var name equals value. Ask questions is if Boolean expression. True expression. Optionally, false expression. Repetition. We have a couple of different versions of this, but we'll just look at the for something in range. So we'll say for I in range 0 to 100, something like that. Some expression. All right, so we'll look at that at the high level. So in Python, we define variables this way. We ask questions this way. Repetition this way. Now we do want to pigeonhole this real quick. Where does Python live in the world of programming? We see these things, and we've placed Python over here, but the reality is modernly Python does live somewhere over here because it's used for a lot more native stuff now with machine learning and things like that. Now just quickly blasting through this stuff, C was a procedural programming language. Procedural meaning monolithic, all code in a row and in a single file, let's just say mostly. Quickest way to talk about it. All right, so C programs were linear, one line after another, go and do stuff. Okay, and it ended up being very difficult to read as the problems we were solving got more and more complex. A pattern we're going to see here is, and this goes across the board in technology, is sometimes a technology that was really, really, really good in its day doesn't hold up over time as we start solving more difficult problems. So C is still considered a great language today, but C predated the idea of object-oriented programming. Okay, we've all heard of object-oriented programming. What does it mean for a language to be an object-oriented language? What does that mean? So I'm going to say C was not an object-oriented language. C++ was. Java is. CSharp is. JavaScript is. Python is. These are all object-oriented languages. And we've all heard the phrase object-oriented. What does it mean? Now, by our pattern so far today, it probably means something pretty simple, right? Usually these techie, sexy sounding names usually are just kind of, hiding something pretty simple under the hood. Like we already looked at like Ajax and React and Angular and all those things kind of just did something simple just with new names to make it, keep people off balance. RESTful APIs were based off of, the great-great-great-grandfather internet protocol. So object-oriented languages, I like to think of these things as kind of like a programming language that has added some Tupperware. So at your house, if you have you're supposed to clean up your room, and you got crap all over the floor and stuff like that. You might get some boxes and label those boxes and put some of the stuff inside those boxes, right? Or we think about how we, I'm just guessing, but for organizing your clothes, you probably have a sock drawer, right? And you probably have a shirt drawer or shirts hanging in the closet or something. You have an area for your shirts. You have an area for your shorts. You have an area for your pants, your socks, so on and so forth, right? Okay. Under your bed, you might have a container listed with the taxes listed on it. You might have a container that says shoes. You know, we organize our lives by creating modules that have commonality to them and putting stuff in it. That's how human beings operate, right? Now remind me, programming languages are meant for us to talk to a computer, right? Now, wouldn't it be in our best interest for our programming language to do as many things similar to how we already do them in real life? We don't want to have to drop down to the 0 and 1 level, do we? 2-button keyboard, tapping it out all day long, no problem. Okay, we'd go crazy in about 5 minutes. All right, so, and now we wouldn't even make it 5 minutes. Okay, we want our languages to be power tools. We want them to let us solve problems the way we solve problems. Right? So an object-oriented language says, you know what? We're going to allow you to create a container and put stuff that is related to each other inside of that container. And now you close the lid on the container and you have an object. You can pass around that object. It has a whole bunch of crap inside of it. But you can pass that object around conveniently. And when you need to get something out of that object, take the lid off, get your value that you need, use it, put it back. Make sense? Object-oriented languages are a level of organization above procedural languages. So I like to think of this in terms of the object-oriented telephone versus the procedural telephone. If you walked into this room today and had this giant pile of wires sitting on this table, and I said this is a phone, most of you wouldn't believe me, right? You know, you come up, you start fishing through the wires, you find the little handset, you find the buttons, you pick it up, you hear a dial tone as if those exist, right? Okay, but eventually you're convinced that is a phone, even though it looked like a pile of wires. That's the procedural telephone. All the details were there. The stuff we need to use and the stuff we don't need to use, but needs to be there, right? Do we all believe that this is a phone? It's a phone, right? Okay. Do we believe all those wires and the equivalents are inside of this? If I crack this guy open, I'll find a whole bunch of stuff in there that I don't directly need to interface with, but is really important that it's hooked up the right way. We believe that, right? Okay. This is an object called a phone, where all the details are hidden inside of it, and only the public interfaces, the part of it I need to interact with, are exposed. This is a container built for holding the details of a telephone that has given me convenient access to the parts of this telephone that I need to use on a common basis. Object-oriented telephone, pile of wires is our procedural telephone. So now we might say, well, why didn't we think of that when we were dealing with C? Why didn't they just give us the Tupperware back then? 1968. What did our computers look like in 1968? Mainframe. What about in terms of power? Were our computers as fast as they are today? Were they faster than people? Oh, yeah. Day one, they've been way faster than us, right? Now, have we evolved in our thinking of what kind of problems we'll solve with computers? Are there things we do today with computers that we wouldn't have done 5 years ago? Do you think the same thing's true 5 years before that? Same thing's true 5 years before that? Remember, go way back to the beginning of tonight's class. Human beings are great problem solvers, and we solve all of our problems in terms of the tools we have available to us. As soon as somebody threw a computer in front of us, we started imagining. We started dreaming of the kinds of problems we can solve with that computer, didn't we? And we're still dreaming today, right? Every new day, there's a new app that comes out. There's an app for that. There's an app for that, and blah, blah, blah. There's going to be, quantum computers before too long, which aren't even based on two-state. Quantum computers are three-state trinary, or base 3. You have on, off, or spin. Where a bit is no longer, it's a qubit, is what it's called in quantum computing. So now you got to reimagine the whole idea of a computing state. Well, once we have that, now we're able to somehow solve even more complex problems. Well, right now that feels like it's quote rocket science, and we don't know how we're going to use that, but fast forward 30 years, it's probably going to be in our phones. It's going to be commonplace, and we're going to be thinking about what comes next. So once we get our creative juices flowing, we start thinking of what kind of problems we can solve with this. Same thing's true. I use this example with our makerspace here on campus. If you guys haven't been down to the new building, the new business building, the free plaster building or whatever, on the main level there, we have the biggest makerspace in the state of Wisconsin. So we have 60-some 3D printers. And if you haven't worked with 3D printers before, you look at them and say, oh, well, that's whatever that does. It looks techie, it looks geeky. You look through the glass, you figure, oh, they must be doing something in there, right? Well, first time you go and learn how a 3D printer works, where you can take a design and print plastic, and now you have something you can actually use, and you learn how to use the tools that are involved in that, and you realize this isn't all that hard. Then you start thinking about what kind of things I can do with this. The example I use with folks is my wife wanted me to start hanging my coat on the back of our door leading to our garage at our house. We have a weird door. It's a really thick, kind of like steel, metal-y storm door thing, but the gap at the top of it is like impossibly narrow, where any of those door hangers you would buy at Target or Walmart or something like that would not fit. The door wouldn't shut. So I designed my own. I measured it. How wide is the door? And then how thin did I have to make the top thing in order for the door to shut? And I designed it in a program called Tinkercad, which runs on a web page, and built just that top part. The part that would just fit over the door and let the door shut until I got that right. Went through like 2 or 3 prototypes. Took me probably 15 minutes to design it and maybe 20 minutes per prototype to print it out. Tested it, finally got it working where the door would shut, no problem. Then I went and found somebody else's 3D model for a door hanger. Took their hanger part off, but took their door hanger part and attached it to mine in the software. Printed it out. 30 cents in plastic later, I had a custom door hanger for my door. 3D printers let you do that, right? That would have been unimaginable years ago. But once you have that tool available to you, I couldn't have bought that for 30 cents, right? I would have gone to Walmart and gone through 5 different renditions at $6 a pop, only to find that none of them fit. So in the end, 2 hours of work or so, well, not really 2 hours of work, probably a total of 20 minutes of work, and then call it 2 hours of waiting for it to print, because it does take some time for molten plastic to print around and then dry. But 2 hours of waiting, I had a door hanger. Awesome. But without learning about that tool, without learning about the process and being able to bring that into my problem-solving world, I wouldn't be able to imagine the things I can do with a 3D printer. Now it's part of my vocabulary. We're sitting around doing something, and like, oh, maybe we can 3D print something. I was talking to a lady the other day who has this super old sewing machine. It's like a 200-year-old sewing machine. And she has a bobbin for it that is like impossible to replace. You can't buy parts for this sewing machine. Well, she had gotten a replica bobbin for this years ago for, I don't know, a couple $100 or something like that. So she brings in the replica and she wants to know if we can create a bobbin for her. Well, we designed one, and we haven't tried it on our printer, but we printed off 20 of them for, I don't know, maybe a total of 50 cents in plastic. So she has 20 backup bobbins. It's like orange. We just used whatever color was in the printer. But that's the type of thing you can solve with that tool. So point here is, well, first of all, if you're interested in learning about the makerspace stuff or getting involved with that, it's free to CS students. So We can teach you how to use it and all that stuff. It's a blast. You just start inventing new things and things you didn't even consider. But the point here is that as new technology comes out and we learn about it, the problems we attempt to solve expand, right? So when C first came out, the kinds of problems we were solving with computers were not nearly as complex as the problems we're solving with computers today, or even 3 years later, right? So eventually we kind of outgrew our first pair of jeans, right? Not that C was bad, as we've already seen today. It's the basis for all of our modern languages. We kept most of it. Even when I'm talking about object-oriented versus procedural, it's not like we dumped the procedural part. We don't always use Tupperware, right? Sometimes we just throw the slice of pizza in the fridge and say that's good enough, right? We don't always organize things. But when it makes sense to us, or whatever, we have that tool available to us. C didn't give us the tool. C++ started giving us that tool. Make some sense? What about Java? What did Java do? Java said, you know what? C++ is pretty solid, but it's a little bit dangerous for beginning programmers. In C++, you have a lot of control over directly working with memory, creating pointers and things like that. And in the early compilers for C and C++, if you introduced a memory leak or something into your program, you potentially could crash your operating system, have to restart your computer because you were overwriting part of memory where the operating system resided. Now they're protected, so that doesn't happen anymore. Now it's more just a joke, even if you're writing old C stuff. Our modern day operating systems have protected memory where the operating system resides. So, and actually even user applications live in their own version of protected memory. So you really can't do much harm now other than just waste memory. You write a C program or a C++ program that doesn't clean up memory after itself, and you end up having this simple program that's using, 11 gigs of RAM or something like that because you just infinitely kept creating integers or something like that and just never, getting rid of them. But the point is that, what Java did is it looked at C++ and said, what can we do better? Well, with C++, inexperienced programmers are empowered to make poor choices. So what do I mean by that? We'll just call it bad. Really, inexperience is better, but just leave it. What do I mean by this? So let's look at a real life example. Let's say you have a party tomorrow night, okay, and you're going to invite your new best friend, right? Okay. So you're saying, hey, Mike, I got this party. It's 8 o'clock. Are you going to hand me your house and tell me to open the door at 8 o'clock? Or are you going to give me the address where your house lives, where your house is?
I'm going to give you the address.
The address, why? Why wouldn't you hand me your house or your apartment?
I'm expecting you to attend my party.
Oh, that's the only reason? The reason you would not hand me your apartment is because you'd like me to come and find it? Could you hand me your apartment? Are you strong enough to lift your apartment? No. It makes no sense whatsoever to hand somebody an apartment, right? Or hand somebody a house. Doesn't make any sense. You give me a little tiny piece of paper or a text message, whatever. Here's the address. This is where you can find my house. You don't hand somebody the house. Houses are heavy, right? C++, you can hand somebody the house. You could choose to do that. Now you told me, again, programming languages, they're allowing us to solve problems, telling a computer what to do, taking things off of our plate, things that we don't want to have to solve, things that are beneath us as human beings. We're going to make the computer do for us. That doesn't mean we're changing the rules. Now, every now and then we might decide, well, because a computer works a certain way, we can sort of kind of cheat. And we might decide to do something a little differently than we might do it in real life. But if we just start with this baseline that we're really trying to do things the way we already do them, but leverage this tool to solve problems for us now that we have this new tool introduced to us, right? But we need to know what this tool can do. Just like that 3D printer, we need to know what all things you can do with that 3D printer. Now we need to know what this tool can do. In order to do that, we got to find out, well, what features does my language have? What are things that are easier than they should be to deal with? You know, we're going to be messing with some of those things in here. So with all that in mind, you said it would never make sense for you to hand me the house. C++ would allow a programmer to hand somebody a house, to say, here is a huge chunk of memory, and I'm going to hand it to you for you to deal with this inefficiently, rather than just tell you the memory address to go and find the value you should be manipulating. And you're telling me in real life you would 100% of the time give me the address to your house, correct? Yeah, just makes perfect sense. So what did Java do? Java said, you know what? We're going to go ahead and make some of those decisions for the programmer. We're going to say, you know what? You are always going to give them the address of your house. Programmer, you don't have the option to give them the house. A lot of textbooks say, if you read Java textbooks, I hate Java textbooks, they'll say pointers don't exist in Java. What's a pointer? How many of you have heard of something called a pointer? What is that guy? Okay. Yeah, this is a variable type capable of holding a memory address. That's what a pointer is. Programmers are typically afraid of addresses. They're afraid of pointers because memory addresses look scary. Get the crazy looking hexadecimal number? It's just a number, right? How does memory inside of a computer work? I mean, our addresses in real life, so if I show you some crazy memory address, so let's just do like UX 12 A B F 32 AAC, something like that. That looks kind of intimidating, right? That number? Intimidating-ish number, right? All right, so now, which is more intimidating? That or 123 Elm Street Mequon, Wisconsin 53097. Which one looks scarier between the two of them?
The above one, but
Yeah.
because we're used to seeing the
Right. Absolutely. Right. Yeah. This one looks scarier. Even though we're smart, this one's far more complex, right? How does memory work inside of a computer? All of the houses are on one big, long street. If we convert this hexadecimal number into its decimal equivalent, this is house 221 million. This is house 0, house 1, house 2, house 3, house 4, house 221 million, all the way down the street. That's where that guy lives. What's this guy? This guy says, first, go to the state, then go to the city, then go to the street in that city. There's a lot more levels there that we have to traverse. This isn't every house is on one long street in the entire planet, right? We got to get to a continent first. Yeah, this isn't even humans can work with this. Computer's going to need even more detail. Let's start with what planet should we go to, and then, stuff like that. But our common addresses, things that we're comfortable with, are way more complex than computer addresses are. Yet this scares us. If something doesn't look like a friendly number, I mean, like if I say go to memory address 7, we'd be okay with that. Okay, well, this is house 0, 1, 2, that's 7. I'm there. As soon as that number starts getting too big, even if it's a decimal number, big decimal numbers make us uncomfortable, right? The second we have to start thinking about how to read it, we're done, right? It's a bazillion. Just a big number, right? We don't care. All right, so pointers are things that beginning programmers struggle with because it's intimidating to deal with memory. So if I say we do something in, here, let's do some code stuff over here. So we'll look at some C here for a few minutes. Let me make sure I have a C compiler. Okay, good. So I'll do vi test.c. So we're going to go ahead and we'll do let's just get a working hello world program going here. All right, so there's hello world in C. All right, so we got our simple hello world program written there. Now, can we read that okay? Everybody can see that? Oh, I'm thinking more font size. Yeah, we can completely kick the lights off if you hit the bottom button there if you want no lights and you see no glare, but I think we'll be able to see what we're trying to do here, all right? Better, worse? All right, let's just roll with it. All right, so anyways, there's our stupid little hello world program. Now we're going to do a couple of things here. I'm going to say int a is equal to 5. All right, and now I'm going to print out a value. So I'm going to print out %d, the value of a. All right, so I've defined a variable. So this is memory, named a, set it equal to 5. Okay, and this is C, just picking a random language. We're going to be doing Python in here, but I'm going to prove a point here. All right, so I've defined a variable. This is an example of how do I remember things in C. Remember earlier I said 100% of programming languages have facilities for memory, asking questions, repetition. This is how you remember something in C. So I'm going to remember something of type integer. I'm going to name it A. I'm storing it in a little bucket called A, and I'm going to set it equal to 5. And then right down here, I'm printing some crap out. That's what this tool does, printf. It prints stuff. And I'm saying, this is a little placeholder. %d says I'm a placeholder for a decimal value. All right, and \n says, press the enter key when you're done. Kick it down a line. All right, and the value I want to put into that %d is whatever A holds. A holds a 5. Okay, so I'll go ahead and run this again, and my output should be a 5. Great. Right, we're all comfortable with that. Defined a memory location named A, put a 5 in there, and printed out the value 5. All right, now I'm going to create an int pointer. Okay, this is a variable, so I'm going to call this guy B. So this variable B is of type int pointer. A pointer is a variable type capable of holding a memory address. I'm going to set B equal to the address of A. B is going to be equal to the address of A. All right. So I'll come in here. Here, I'll just put it on the next line. We'll do a printf %p \n, that's for a pointer. And I'm going to print out B. This says print out. This is a placeholder for a value. % something is a placeholder for a value. This is a value of type pointer. I want to print out the value of B. What's the value of B? The value of B is equal to the address of A. B is built to hold an integer pointer. A little asterisk there at the end of it says, my type, int pointer. I'm capable of holding a memory address of an int. So what do I expect to print out on that line?
The memory allocation of A.
Yeah, scary memory address thingy, right? All right, so come out here, run this guy again, and there's scary memory address thingy, FFFAC4C8. Memory address. Both of these guys are just variables. This is a variable. This is a variable. This variable knows how to hold a whole number. This variable knows how to hold the address of a whole number. Where is that address stored inside of the computer's memory? What house is it in? Make sense? Now, if I want to print out, I'll just flip these now. I'm going to print out %P up here, but it's going to be the address of A that I'm going to print out. Address of A. So I'm going to print out a pointer. Pointer says memory address. What address? Whatever, wherever A lives. This is the address of A. Let me just do something here real quick. That better? You good? All right, so variable A equals 5. Variable B is equal to the address of A. In this case, I'm printing out a pointer. What value am I going to print out? Whatever the address of A is. The address of A is a memory address. Memory addresses are pointers. That's what they are. Down here, I'm printing out a pointer, and I'm printing out B. Well, B's value is the memory address of A. B happens to be a variable capable of holding a memory address. So now I'll get that memory address, that same memory address, printed out twice. Similarly, if I want to come down to the second one here, and I want to print out a decimal value. What decimal value? I want the value that lives at the memory address that B holds. You put a little asterisk before it that says the value at B. This is equivalent to running down the street, going to the house number, banging on the door, and having whoever's inside come out. The value that lives there. So star B is a int, because B is an integer pointer. Therefore, B holds the address of an integer. Star B is that integer. It's the actual integer. So run this. Now we'll have our 5 as that second value. That makes sense? All right. Now, throwing aside any sort of intimidation of the C syntax stuff there and things like that, what I want us to get from this is the idea that this is a variable, this is a variable. These are both variables. These are both ways of remembering a value for later use. This first one, I've said A is going to be equal to something. This second one, I'm saying B is going to be equal to something. Later on, when I need the value of A or I need the value of B, I will call upon them and I will get their value. Down here, I'm using the value of A. And the value of A is a 5. But I'm saying, tell me not the value, but tell me where you found that value. That's what that little ampersand before it says. Give me the address. Where did you dig them up in memory? Down here, the value of B is an address. Star B says, I want to know the value that you found at that address. All right, but in both of these cases, I'm using the value of A and the value of B, and then I'm deciding what to do with that value. Okay, in this case, I'm saying, I want to know where you found the value. In this case, I'm saying, give me the int that lives at that address. But variables are our way of storing values. This guy holds numbers. If we look at these two lines, just completely separate, this line is less scary than this line, correct? Second line has weird symbols and stuff in it. Okay? Now, memory is always intimidating for beginning programmers. Throws us off. We don't like dealing with crazy looking numbers, yada, 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 all sorts of stuff like that. Okay? But at the end of the day, do we believe that it's just doing the same thing? A is a variable that holds a value. B is a variable that holds a value. Those values just happen to be different kinds of values. I can create a value. Let's see, where am I at here? I can say char C is equal to the character A. That guy's not that scary either, is it? I have a character named C, and he's going to be equal to the letter A. He's certainly more comfortable than the middle line. Middle line's still intimidating, even though all three of those are saying, I'm defining a variable equal to a value. I'm defining a variable equal to a value. I'm defining a variable equal to a value. Make sense? All right, so now we had our example here of us thinking about, in like C++, we're empowered as a programmer to make decisions of what we do with memory. When we just used a real life example with the party that what you said was 8 o'clock tomorrow? So the actually we'll be in class at 8 o'clock tomorrow, won't we?
No, I don't have a class with you.
Oh, you don't have a class with me tomorrow. So I'll be in class at 8 o'clock tomorrow. But yeah, so we decided in real life it would never make sense for him to give me the house. It would always make sense for him to give me the address of the house. Here, I'm looking at, I see I have the options. I can say, here's the address of A, or I can just say A. This is the house. This is where you can find the house. Now, the number 5 isn't that big, so it's not really a problem if you hand me a 5, right? We could say, well, it's kind of light. No problem. I'm going to kind of toss it up a little bit. Okay. The address of A, thought that it was called a 32-bit operating system. The address is 32 bits big, so 4 bytes. So this weighs 4 bytes is the address of A. A is also an int, 32-bit integer. It weighs 4 bytes. So address, value, weigh the same. Okay. We call that a toss-up. Right? Okay. But important example here is that the programmer gets to decide what you're giving me. You got to decide if you're going to give me where to find the A or the value that A has in it. Real life, you go up to somebody, ask them to borrow a quarter. They can either hand you a quarter or tell you where you can send you on a wild goose chase to go find a quarter that you think you saw on the ground in Walmart's parking lot. Right? If you have a quarter on you, you're probably going to hand them a quarter. You're not going to send them off on some voyage to go find a quarter. But if you're inviting them to your party, you're going to always tell them where they can find your house, not hand them the house. Because now it's not so even, right? That address, still 32 bits, 4 bytes. So whether he's giving me the address of the number 5 or he's giving me the address of his house, only weighs 4 bytes, no problem. Now when he hands me that house, heavy, way more than 4 bytes, right? That would never make sense. In a modern language like Java, Java makes memory pointer decisions for the programmer, allowing them to focus on logic rather than memory. What a lot of textbooks, Java textbooks, say is that pointers don't exist in Java. How many of you have ever heard that? That pointers don't exist in Java. Let me show you a quick example here. So you don't have Java on here? Yep. So we're going to do vi test.java. It looks like a memory address to me. Go back and show you the syntax here. So this is the Java. Can I stretch this out here? There we go. So Java program. I went ahead and defined an integer array. I printed out the value of that integer array. AR is a pointer. It holds a memory address. There's the memory address that was in there. Java runs in a virtual machine. So Java actually creates a layer of fake Java memory on top of real memory. So this guy says this is the integer array that lives at memory address 7E868. That's how you read the memory address. But it's a memory address. That's apparently not supposed to exist in Java. Didn't take very many lines of code to get to a memory address. All right? Java just made the decisions for me. What Java actually did here is they removed any sort of special syntax for this stuff. So for instance, if I'll just So I'm creating an object called R. I don't have any pointer syntax or anything here. I don't say random star or anything like I did before. I said int star A or int star B, whatever it was. All right, then I'll come in here and I'm gonna print out R. Another memory address. This is the random object that lives at memory address ED5528, hexadecimal value. We almost can't find things that aren't memory addresses in Java. Okay, but what we can't do in Java is I can't define a variable named A and set it equal to 5 and then get that guy's memory address. Java doesn't give me a syntax that allows me to grab memory. Java handles it all for me. If something is a pointer, Java will deal with it as memory. If something is not a pointer, Java won't let me touch it. Make sense? Java's making all those decisions for me as a more modern language. Look at our lineage here. Java is an updated version of C++. Now, C++ is still pretty popular, especially for video games, because I mentioned a minute ago, Java runs in a virtual machine, right? But now the reality for us is that we've talked a bunch about virtual machines today, right? These hypervisors, a machine running on top of another machine. Whenever you have a translator there in the middle, do you think things slow down? Probably. Okay, so even though I'm running Linux here in this thing and it seems to be running fast enough and things like that, it's not running as fast as it would run on this hardware native. There's some translation happening there in the middle. Now, what's funny is when Java first came out, its original goal was, it was funny. We're right back to ripping on the Apple people. back then, a lot of the Apple folks were screaming and yelling that, well, such and such software comes out for Windows, and then we have to wait at least a year or two or it never comes out for Mac. So they were screaming and yelling. They wanted stuff to come out at the same time for the Mac operating system as it came out for Windows. So Java's claim to fame was this idea that it's platform independent. You write it once and it runs anywhere, right? It runs on a Mac, it runs on a PC, it runs on Linux, it runs on any of the platforms that support the Java virtual machine. So rather than write the program multiple times, like if you were writing a video game in C or C++, you would have to compile it once for Windows running on the Intel architecture, and then you'd have to compile it again for Mac OS running on the PowerPC architecture. And you might have to make changes to the source code. You might have to port that source code. If you're writing a Windows game, Windows games are often written for a library called DirectX, which is their graphics library. Where if you're writing it for any other platform, you're usually writing it in OpenGL, another open source graphics library. So that's where games are either compatible with both or compatible with one. Now, having said that, go back to this period of time, they said, well, why don't we write our application using Java syntax, and we'll port the Java virtual machine to Windows, and port it to Mac, and port it to Linux, and port it to cell phones. So if you have a Java executable, a compiled Java program, you can take that compiled program and run it on the Java virtual machine on Windows. You can also run that identical program on the Java virtual machine for Mac. So same program will run on any Java virtual machine. It was the Java virtual machine that they wrote multiple times for the different platforms. Make sense? But that came with a trade-off of some performance. So business applications, great. All day long, Java's great for those. But games need to be fast. If you're talking about something like Angry Birds, you're probably fine with Java, right? But if you're talking about something like Battlefield or pick your favorite game with explosions, Java's probably not your go-to move. You want something that's going to give you a better frame rate, lots and lots of computation power, whatever. Okay? Now, where does CSharp come in? So if we look at so we'll say Java, this guy is platform independent, runs on any platform that supports the Java virtual machine. All right, write it once, run it everywhere. Who makes C#? Microsoft. Good guys, right? Microsoft stole Java. In fact, they even included it in their Visual Studio product. They had their own Microsoft virtual machine, Microsoft Java virtual machine. They wrote their own Microsoft Java virtual machine. They had inside of Visual Studio, their software development platform, they had a product called J++. And later on, they had another one, this is right before the end, called CSharp. This preceded C#. It was the lead up to C#. Right? So they stole Java. Do you know who made Java?
No, the original Sun.
Sun Microsystems, yeah. So Sun Microsystems made Java. Funny trivia thing. Sun Microsystems was a publicly traded company, right? So just like Apple or Microsoft. Do you know what their ticker symbol was for the stock market? Java was their ticker symbol, which is very interesting because they never figured out how to monetize it. Sun Microsystems probably ran into problems because they really had a great platform with Java, but never actually figured out how to make it into a cohesive development environment. Where Microsoft has really won is that you get their Visual Studio product and it brings all of the Microsoft stuff together into one product. Love them or hate them, it doesn't matter, right? Visual Studio is a great tool. But more importantly than how good or bad the languages might be, is it brings all their stuff together. Microsoft SQL Server, all their .NET web stuff, all the different parts of the development community, Microsoft Azure development, their cloud stuff. All that comes together in one tool that you can just do everything from. Java never made it there. Java had like 50 different tools that solved 5,000 different problems, and every single one of them required a whole separate install, a different tool. They weren't compatible with each other. They had all these problems. They just never really brought all the stuff together. But interesting trivia thing is Sun Microsystems, their ticker symbol for the stock market was Java. The thing that represented their value in money was the thing that made them not make money because they couldn't figure out how to sell it. But in any case, Microsoft stole Java. Really what they did is they stole Java's syntax. So they took Java's syntax and put it into their own language called J++, which was made for writing at that time, it was MVC applications, Microsoft Foundation applications. And then later .NET was kind of like this was right before .NET was kind of starting to become a thing. Now, any of these big companies, we don't want to necessarily demonize Microsoft, but any of these big companies, when they, we can maybe say it's the American way, but maybe it's really the capitalist type way. If you design some software in your basement and Microsoft steals it from you, and then you sue Microsoft and they settle with you outside of court for $1 million, you're happy, right? You made $1 million off something that you probably wouldn't have been able to generate $1 million off of. I mean, we don't know. We don't know what the idea was, right? But chances are you didn't have the resources or the marketing power or whatever to turn that into that much. So you're actually thankful that Microsoft stole your project and then paid you for your trouble. What did Microsoft do? They saved themselves a whole bunch of time trying to negotiate buying something by just stealing it and paying the penalty. Okay, this isn't a Microsoft problem. This is, our laws allow this, right? So in this case, Microsoft did something that they had done before that other companies have done before as well, right? They just did it to the wrong person. They did it to Sun Microsystems, thinking that, oh, well, what are they going to do? Well, Sun Microsystems isn't just some kid in his underwear coding in his grandma's basement. They are a publicly traded company that, at the time had a major hardware division. I mean, they were basically running the world of Unix servers with their Spark stations. They had their own processor called Sun Spark, SPARC, and a Unix operating system called Solaris was their Unix operating system. They had two death knells. They couldn't figure out how to make money off Java, and they decided to make Solaris Intel compatible. Same problem Apple ran into. When they had their own Spark chips running their own software written for it, they controlled both sides of the coin. As soon as they started saying, hey, Intel people, you can use our crappier version of our Unix software on your hardware, game was lost. Stay proprietary, stay expensive. That's the name of the game for them, right? Other people, other businesses, their name of the game is budget. We have these models. You can attach it to restaurants. You can attach it to stores. You can attach it to cars. We see the same thing. You walk into a Chevy dealer, you have a number that you expect the most expensive car there to not clear. You walk into a Ferrari dealer, the number's a bit higher, right? Cars are still made of metal, right? A lot of the parts are shared. So it's kind of that type of thing. But anyways, Microsoft stole their syntax. Sun Microsystems sued them, lost. Well, Microsoft lost. Sun Microsystems won the lawsuit. So Microsoft had to give up, get rid of their J++ and CSharp products. So this was right around, I want to say 2000, 2001, 2002, something like that. I was at an ACM conference in Champaign, Illinois, at the University of Illinois, Urbana-Champaign. And Microsoft was there. And whenever you go to one of these conferences, and Microsoft's there, you always go to Microsoft's presentations. What do you think? Why do you go to Microsoft stuff? Best free stuff. Best free stuff. You know, guy next door was handing out bouncy balls. What do you think Microsoft gave out there? Visual Studio Professional 6. It's about a $1,000 piece of software. Handing out for free. Now, this was in the early days of eBay, so you know where that went. You know, because we already had a site license for it. And by site license, I sort of mean we probably already were running it not in the way we were supposed to. But we'll just call it a site license. Don't do that, by the way. Ethically, it's bad. But anyways, they were giving out really good free stuff. So that day, they were introducing a top secret product that they were working on called CSharp. First public announcement of CSharp. It's right there in the front row. And this guy was up there, and I was a Java, I would say if I had to pick my main language at the time, it was Java. Now I don't even know what language I program in a lot of different, it kind of drives my mood on a given day. But I would call myself a relatively Java fanboy at the time. And this guy might as well have been standing up there describing Java. Every little idiosyncrasy of what's the cool, you know, we've built this language from the ground up, but it does this. Well, Java does that, and it does that. Well, Java does that. But it had slightly different syntax. Slightly different syntax. You know, you can take a Java program and change like two things. Like make a couple things lowercase that used to be uppercase, and maybe one other little change, and it will work. They're really similar languages. But that's okay, because all they had to do is not use the identical syntax. This isn't really demonizing Microsoft, because you know what? Java looked a heck of a lot like C++, right? So, I mean, you can only change stuff so much before you're like, well, who owns the curly brace, right? So, now one interesting thing, though, about C# is that it was platform independent. Now, this was the thing that Java was yelling constantly, that we're platform independent, you write it once, you run it anywhere, because this was during a time period where it was a major issue. If you were working on Macs, you couldn't really open your files on a PC. They ran different file systems, they weren't compatible with each other. You put this is days of floppy disk. You put a floppy disk in and it would say, do you want to format this disk? You know, like, well, I was just using it over in the other machine a second ago. You know, these are worlds that weren't really connected to each other. So this idea of having a program you can write on any machine and have it run on any other machine was a really big deal. So, and this is pure Microsoft joy here, the way they announced this. So it's platform independent. The way it works for Java is we just draw a picture here. So you take your Java source, which goes through the Java compiler, which turns into, let's just type it out, which turns into Java bytecode, which turns into, which is then runnable on the Java virtual machine, which then runs on the native CPU. That's how Java works. Write a Java program, compile it, run it, Java virtual machine. Here's my Java bytecode, test.class. That's the output of the Java compiler. When I go to run it, I'm running it on the Java virtual machine. It's called Java. I run test. That's me running it. Okay? So that's how the Java architecture works. Now, let's look at how drastically different the C# architecture is. C# source goes through the C# compiler, turns into something called missile code, Microsoft Intermediate Language, which then runs on .NET, which then runs on the CPU. Drastically different, obviously, right? I just kind of renamed a couple things there, right? Now here's what's funny. Now, first of all, I'll say this guy is better. I'll talk about why in a second. But first, we got to hear the funny Microsoft thing. It's platform independent. It will run on any platform that supports the .NET component architecture. Any platform at all, as long as it's Windows. The .NET component architecture only runs on Windows. Now, could they write it to run on Mac and Linux? Well, probably. But hey, it's platform independent. It'll run on any platform that supports the .NET component architecture, just like Java will run on any platform that supports the Java virtual machine. The difference is the Java virtual machine is on multiple platforms. The .NET component architecture is not. So C# completely platform independent as long as you're running Windows. All right. Very funny. And this guy was completely straight-faced up there saying this. It was hilarious. But one thing where C# does have a lead here is this last step. When you first write a C# program, the first time you run it, this Microsoft Intermediate Language gets translated into native low-level code for that CPU. All right? From that point forward, the next time you run that program, it's running natively on the hardware. It's not running through a virtual machine. So instead of every time I run my Java bytecode, I'm running it through the virtual machine, only the first time I run my C# bytecode, it's running through a converter that makes it native code for the CPU. So from that point on, it's faster. It's a native application. But projects have been born out of this. If you've ever heard of a project called Mono. So the Mono project allows you, so this is an open source .NET framework. .NET is not open source. Microsoft owns .NET, right? And it's not an open source project. So what these guys have done is they've tried to estimate what .NET does. They try to figure out all the things that .NET knows how to do, and they give you a framework that functionally is equivalent to most of .NET. The parts of .NET that aren't like integrally married to the Microsoft operating system. So with that in mind, you can write C# code on Linux or on Mac if you have ever done any game programming stuff with a tool called Unity. Unity's scripting language is C# because it uses the Mono framework for their scripting. Because they're not writing native Windows applications, they're just making things jump up and down on the computer screen and things like that, which just requires a programming language. Why do they choose C#? Well, it's a popular programming language. Maybe a lot of our developers who are going to be using this tool will know C#. Why did Node.js pick JavaScript as their core language? Because the people who are the front-end developers are JavaScript programmers. The people who are the back-end developers might also be JavaScript programmers. So let's have them use the same tool. All right. What we're going to start talking about next time is the nature of the CPU, low level, well, 3 types of programming languages. Machine, low level, and high level. And we'll pick up there now for next week, if we just jump in here. The homework, I have to re-log in. Give me a moment. The first 2, since most of what you're going to be accomplishing for next week is this. You're going to be reading 4 chapters out of the book of Luke and writing 4 or 5 sentences total across those. Turn those in as your Bible homework. Okay? So if I go in here to, what class is this? Yes, so here I'll show you. So under Bible homework here, Bible homework number 1, read chapters 1 and 2 from the book of Luke, and then, write a few paragraphs reflecting on what this means to your life. That's if you're able to. What am I really doing? I'm forcing you to read a couple books from the Bible. All right? Read the 2 books, read the 2 chapters, write a couple of paragraphs of how it relates to you, relates to your life, submit it for that assignment. Bible homework number 2 is also due next week. Again, we're compressing this into a lot fewer weeks than we really should be. So you're reading 4 chapters out of the Bible. This shouldn't take any more than 15 minutes of your life. Okay? So those 2 assignments are due next week. Also, under drill assignments, drill homework 1 is due, drill homework 2 is due. Drill homework 1 is both of these are papers, short papers, 1-page papers. Because as you noticed today, we're doing a lot of background stuff. Hopefully good stuff. Hopefully you heard a bunch of stuff today that you didn't already know. But we're building up a foundation that we're going to build everything else on top of. So I need to have you dragging behind it a little bit. So first paper is a 1-page paper on SQL. So research SQL, tell me what it is, what role it plays in modern programming, yada, yada, yada. Okay? Other 1-page paper, comparing Python 2 to Python 3. All right, there's 2 different versions of Python that are out. We're moving towards just Python 3, but there was a point in time where they both existed. We're currently still in that point of time where they're both technically still supported. Why and how are they different? Okay, we're going to be using Python 3 in here. That's the second assignment. The third assignment, and the best way to visualize this, I think I showed you earlier, but let me just show it to you again. Under Course Tools, go to Course Calendar. This is the cleanest way of seeing what's due when. So for the 5th, a week from today, drill homework 1, drill homework 2, project 1, and the first 3 Bible homeworks. So 6 total chapters in Luke. 20 minutes of your life. All right. So project 1, so the very first project assignment is due. That's this guy. So this is write a 3-page paper on the history of programming languages, focusing on where Python fits in that historic lineage. So that is effectively a focusing on Python relative to this slide. Make sense? Okay. You don't need to follow any sort of special writing format. If you're going to quote something, just, give me some sort of citation at the bottom. I don't care if you're following a certain standard or something. Just use your own words, or if you need to use somebody else's words because it's important, put it in quotes and tell me where you got it. Okay? So I really want you to learn from it. I'm not looking for amazing writing technique and things like that. Don't make it suck. Make it readable, and I expect, to check your, errors and stuff like that, make sure things are spelled right, that kind of stuff. Put some effort into it, but I'm not going to be like, oh, you're missing a comma, -5. I'm not going to be looking for that stuff. Okay, but then what I want you to accomplish between now and next week is get a virtual machine or get Linux installed in one way or another. On Blackboard here, I've given you a video of installing Raspbian Linux, which is the Linux I've been demonstrating for you here. It's the one that's designed to run on a Raspberry Pi. get it running in VirtualBox, which is a free piece of software. So if you just watch this video and mimic that on your computer, that would be a good starting point, because I want you to be using Linux to do your assignments. And if you start turning assignments in, you're going to be programming assignments, you're going to be turning in screenshots, and those screenshots need to show me you did this in Linux. Okay, so whether you accomplish it through a virtual machine, dual boot, get a Raspberry Pi and run it separately, I don't care how you accomplish it, get Linux on your machine. If you don't want to run Raspbian, you want to run something else, that's fine. Do it in Linux. Cool? Questions, comments, concerns, bribes?
Do you care if the papers are like Microsoft Word? You don't care about
No.
that? Okay. And like the Bible piece needs to write in the text?
Yep. Yeah, as a general rule, don't turn in zip files. So I prefer PDFs, Word documents. Those are better than pages. I can read pages on my Mac. The problem is I do a lot of my grading in the swimming pool. Not kidding. So that means I need to be able to read the format on my phone. But I can read most formats. I don't think you have to worry too much. What were you about to ask? Sorry.
Any questions go on Slack then?
Slack, email, I think I have my.
Do we have a channel for this class?
Yeah, we talked about that at the beginning. Weren't you paying attention 4 hours ago?
I was like 200.
Look at this, 535. Right here, go on Slack. There's a 535 channel. Here, I'll put.
Do you add us to the channel?
Well, you have to join the. Just join the channel. Double click on it.
All right.
Yeah, but Slack is the best way. That way everybody in the class can. So for instance, if I just show you real quick, I have one of my other classes putting Raspbian on their machine. In the 200 folder, you might go in there because somebody was having this like black screen problem and somebody gave them a solution for it. But as you're going through, common experiences like that, put stuff up on Slack and ask questions, and if I can't give you the answer, I'll try to get somebody in front of you who can, or maybe one of you figured it out and can help with that stuff. But also, if we're working on your homework, feel free to set up a Zoom meeting or something like that and work on the stuff together. I mean, papers are, you can do whatever you want. I don't care. But, for programming stuff, you might want to work in groups. I don't care as long as you learn the stuff. But Slack's a good thing. Text me is a good way of reaching me. Email's a good way of reaching me. Telephone is the worst way to reach me. My mom knows only to call if it's an emergency. She texts first and said, "You have time to talk." Okay, so I pick up the phone for my mom and my wife. If you're not in that list, your phone's not getting picked up. All right? Make sense? And if you do email me, you don't get a response within maybe an hour during waking hours, send it again to bump at the top of my list. I get a lot of messages each day, and I'm usually pretty good at replying to stuff almost instantaneously. So chances are it fell off the top of my inbox. I would rather you bug me 4 times and get an answer than me responding. All right, have a good one.